Okay, what we're looking at here is the function, the absolute value of x, okay? And it gives us a really neat looking function, which is basically a V shape, okay? And these absolute value functions are really helpful in trying to understand transformations because it's such an easy shape to recognize, okay? And so one of the things that we can do is we can, let's see, what would it look like if we did g of x. Let's start with, let's go ahead and make the absolute value again, and we're gonna make this one blue or purple. Let's make it purple. There you go. Okay. All right. Now you'll see that it's right on top of, because we have the exact same function here. But if I wanted to do a vertical reflection, then we know that what I would do is I would just simply do the negative of the function, which would be the negative of the absolute value of x. And you can see now that the whole graph is now below, it's upside down. It's below the x-axis, okay? If the function that we started with looked something like this, then our transformation would look like this. You could see that the parts below are now above and the parts above are now below, okay? But let's go back to the original. And all right, so now let's say g of x, we want to transform it. Let's do a stretch, okay? Well, if we wanted to stretch the whole thing vertically, we would just multiply by something like 2. And so look at that. You can see that this purple graph is vertically stretched. Now, it doesn't look like it's vertically stretched because it just looks like it's a tighter V, but that's essentially what would happen when there's a vertical stretch, is it becomes tighter, okay? What if we did a vertical shrink? Well, like 0.5. Well, then it would look like this. Okay. Now, what's interesting is if we did a horizontal stretch, it would actually look very similar. Let's see here, 0.5. See that? And if we did a horizontal shrink, it would look very similar. Okay, so the absolute value actually gives us a similar look both ways. But don't worry about that too much, okay? In fact, with the absolute value symbol, I would just stick with the vertical, not the horizontal. We're just going to do a vertical, and we're going to stretch and a vertical shrink, okay? Now the last thing we're going to look at is what if we were to shift this thing left, right, up, and down, okay? Well, up and down is really easy. Let's do like a +3 shift, and you can just see that it's just the red one is, the purple one is just 1, 2, 3 units up, and it's the exact same shape. We could also shift it, let's say down 4, put a -4 on it, and you can see that it's shifted down 4, okay? And then of course we can do a left shift or a right shift, which would be like, let's say -5, and so you can see that it moved over 1, 2, 3, 4, 5 units to the right. And we can also do a left shift, which would be, let's say, a 3 units to the left. If we put +3 on there, you can see that it's going 1, 2, 3. Okay, so now I want to show you a way that we can understand these shifts and transformations just by looking at the vertex here, okay? So look at the origin, look at where the vertex is. It's at 0, 0, right? Well, let's give this a rightward shift of 3 and a downward shift of, let's say, 7, okay? Well, we can understand the shift by just simply looking at going to the coordinates of the new graph, the g of x. So this point right here is 3 to the right, so that's 3, and then down 1, 2, 3, 4, 5, 6, 7. So we know that because the vertex here is at 3, -7, that's going to be an x -3 and then a -7, okay? Another example would go like this. What if we had a 2, or let's say a -2, and then an x +4 with a -1, okay? And so what we would do here is from the origin, we could go and say that this point is at -4, -1. And so that means that it's going to be an x plus 4 and a -1. So that's going to tell us our shift. So the vertex just tells us the shift from the origin, x plus 4 and then -1 on the end. The fact that it's upside down means that it's negative. It's a reflection. And the fact that it's narrower than the original absolute value function means that it's a vertical stretch, and that means that it's going to have a number in front of it like 2 or 3 or 4 or something like that. Okay? And so these are just some examples of how we can recognize transformations of an absolute value function.